Hello everyone, and in this lecture video I'm going to show you how to use the formula for Ohm's law. So if you guys recall, Ohm's law is I equals V over R. So here's my example number 1. I'm going to have a resistor, and this resistor, I will know two pieces of information about it. I'm going to know its resistance. Its resistance is exactly 100 ohms. And I know that the voltage drop of this resistor, I'm putting V of R because it's the voltage drop of the resistor, is exactly 5 volts. So what I need to do is I need to find what is my current. So look, I have exactly two pieces of information, and my formula can give me 3, right? So I know that current equals V over R. This, in this case, is straightforward use of formula. So all I have to do is just plug in my numbers. So 5 volts over 100 ohms comes out to 0.05 amps. Now I have a little problem. In your assignment, I want all of your answers in engineering notation. But 0.05 amps is not an engineering notation. I need to put this number into the engineering notation, and SI notation really. So I'm going to go by 3. Now I'm going to have 50 times 10 to the negative 3 amps, and I need to select the correct prefix. 10 to the negative 3 means milli. So my current equals 50 milliamps. And if I were to put this into my assignment on the hub, I would put a space in between the number and the prefix. So the space goes right here. Okay? All right. So that was example number 1. Now let's do example number 2. So here's my example number 2. Once again, I have a resistor, and this time I know the current passing through it. I know that there is a current going through, and that current is 10 milliamps. I also know that this resistor has a resistance of 100 ohms. So this time I need to find voltage. Well, if you look at my formula, it's I equals V over R. So now I need to find voltage, so all I do is multiply by R both sides, and I get V equals IR. So that's all I need to do. So now I need to plug in my numbers in there. But I have a little problem. My current currently is measured in milliamps. You cannot use a number that has a prefix in it in your calculations. You need to switch to engineering notation beforehand. Well, there is nothing to it. 10 milliamps is just 10 times 10 to the negative 3 amps. That's it. So now I'm finally ready to plug in. So V equals 10 times 10 to the negative 3 times 100. Well, if you look at all of this all is really 10 to the 1 times 10 to the negative 3 times 10 to the 2. And this all comes out to 10 to the 0. And that is just 1. So my answer is 1 volt. My answer is 1 volt, and I'm very lucky in this particular case because 1 volt is definitely an engineering notation, so I can just plug it plug it in as it is. I don't need to convert anything in this particular case. Now let's do example number 3. Once again, I have a resistor, but now I don't know its resistance. It's a mystery. I do know that the current passing through it is 5 milliamps, and I do know that the voltage drop, the amount of voltage that that resistor is going to use up, is going to be 10 volts. So once again, it's a straightforward application of the formula. My formula was I equals V over R. If you solve this problem for R, you're going to find that R is V over I. Very, very simple. But before I can plug in anything, I need to make sure that all of my numbers are in engineering notation and not in SI notation. So I need to do one little conversion, right? This is 5 times 10 to the negative 3 amps. Now I can finally plug in. So R equals to 10 volts over 5 times 10 to the negative 3 amps. Like I told you before, you split up your numbers and your exponents, right? This is 10 over 5 times 1 over 10 to the negative 3. If you guys remember your numbers, your powers review assignment, you guys will remember that this is just 10 over 5 is 2 times 10 to the 3. Because when we flip the exponent up, it changes sign. And this is ohms. Of course, I cannot put this answer into the computer, even though it's an engineering notation. I need to put it in SI notation. So when I do that, I'm going to end up with 2 kilo ohms. You may have noticed that the keyboard on your computers does not have a letter omega on it. So what we need to do is we need to type it in a way that is understandable to the automatic grader. So this is what you're going to do. You're going to put your number, you're going to put your space, you're going to put your prefix. In this case, it's lowercase k, and then you're going to spell out the unit, the word ohms, just like that. This is, after all, a last name. And this is it for the examples for today. I hope that really helps you with your Ohm's Law practice assignment. And feel free to revisit this lecture anytime you need a refresher on Ohm's Law.